In this video, we're going to begin to learn about thermodynamics, a big branch of chemistry and physics. And we're going to begin with the idea of spontaneity. And so thermodynamics are calculations that predict whether something will happen or not under a certain set of conditions. If something happens on its own without any outside intervention, such as like raising the temperature, we call that spontaneous. The idea, or one example is this car. If you leave a car outdoors, it is going to spontaneously rust over some given time. Now, if we wanted to unrust this car, that wouldn't happen by itself. It's not spontaneous. We would have to put in some kind of energy to get rid of that rust. And we determine if something is spontaneous based on potential energy. And for chemistry, we use chemical potential energy. And the idea is, if something lowers its potential energy, then that process is going to be spontaneous. Things generally want to be low energy. They do not want to be high energy. And we can take a look at some of the examples about lowering potential energy in the next slide. But something to keep in mind in this class and any future class that talks about thermodynamics you may take, just because something is spontaneous does not tell you how fast or slow it will go. Thermodynamics and kinetics, which is the speed of things, are not the same thing. Something is spontaneous, you cannot tell me the speed of that reaction. So let's look at some potential energies, what I mean by low potential energy. We're going to start with an example that should be familiar to everybody. So let's say you have a weight on a pulley. Now, that weight is not spontaneously going to rise by itself, because as you raise a weight higher and higher and higher, you will increase its potential energy. So you have to do this non-spontaneous process of raising a weight by putting energy into it. As soon as you let go of that rope, that weight will spontaneously fall to the ground. That is a spontaneous reaction. For chemistry, we can look at salt. So if you put salt in water, it will spontaneously dissolve based on the principles we talked about way back in chapter 11. Salt will not form a solid in water unless you're above the solubility limit. So it has a higher potential energy in its solid form and a lower potential energy in its dissolved form, so salt spontaneously dissolves. And the last example is diamond. Diamond is made under conditions of very high pressure and very high heat. Eventually, though, all of the diamonds in the world will spontaneously change back to graphite. It's going to take a long time for that to happen, but it is spontaneous. So no, diamonds are not forever. In our lifetime, they may be forever, but not in the Earth's lifetime. They are not forever. And the way, like I said, you determine if something's spontaneous, we can use a graph like this. So here we have energy versus reaction progress. We have reactants and we have products. Here's the energy barrier we have to get over. So we have to put this much energy in. And here's our final and initial potential energies. So you can see this reaction, if it goes to reactants to products, we would actually increase our potential energy. So this reaction would be non-spontaneous. We would have to put some kind of energy into our system to make this reaction happen. That's it for this video. I will see you in the next video.